Good morning, dear students. Welcome to this session on pre-stressed concrete. Uh, till the last session, we have been discussing the total losses calculation for the case of pre-tension and post-tension members. We have seen some examples also. First two examples on pre-tension member. Okay, then the example on both pre-tensioning and post-tensioning members. Now let us see some more examples and close this unit 3. Okay, this will be the last session for unit 3. From next session onwards, we'll talk about the unit 4 uh, design of pre-stressed concrete members. Okay, right. So question 517 example. A concrete beam of span 12 meters is post tension by a cable which is concentric at supports A and B and has eccentricity 200 mm in the middle third span with a linear variation towards the supports. Okay. Uh, yes, if the cable is tensioned at the jogging end A, what should be jogging stress in the wires if the stress at B is to be 1000, the other end? Assume the coefficient of friction between the cable and the duct and concrete as 0.55 and wave effect is this. So this question is only for frictional loss. Let us see. First, understand the given question. So this is like 12 meters. So break this into three equal parts. Just for example. Okay. So this is like CG of concrete. Let us say CG of concrete. Uh, no, there is no information on the size of the member. So depth we are not sure what it is. Only the span is given. And eccentricity value is given. So middle third. This is the middle third portion. So this middle third is having an eccentricity of 200 mm. Okay, and with a linear variation towards the support. It is concentric at supports. Concentric at supports means zero eccentricity. Zero here. So just join by straight line. Okay. So not able to draw a straight line. Still not able to draw the straight line. Okay. Let us try in this manner. Better. Yeah. Find some way. Right. So just yeah. This is somewhat better. Right. So this is how the cable is. Right. So 200 in the middle third portion and linearly varying towards support to zero eccentricity. Right. So the slope value that you are calculating is only for this end portions, only for this portion and only for this portion. Middle portion there is no slope at all. So slope what you calculate is like 200 divided by 4 meters is 4 meters, right? One third. 4 meters means 4000. So 200 by 4000, which will give you the slope at one third portion. So total change of slope two times in the entire portion. So from first one third it is 0.05 plus 0 in the middle third, then after that again 0.05. So total slope is 2 times 0.05. This is this one. Right, next. Now, so we have a formula Px is equal to P naught into, forget about this one, that's not necessary. Or else if you can straight away substitute it here if you want. Okay. Instead of writing this step, you can extend this procedure. Okay. Right. P naught 1 minus mu alpha plus kx. Okay. Right. You know that what question says, what if the cable is tensioned at jacking end A, so there is a jock at this end, there is a hydraulic jock at this end, okay, and the anchoring is done at the other end. So jacking is done in this end, so pulling is happening end A, so other end is B, unjocked end. Okay, so what should be jacking stress in the wires? If the stress at B is 1000, the stress at B is 1000 means what? After all losses, after friction loss, stress is 1000. Means what? Px value is 1000 and P naught is the stress in the jacking end. So this is unknown value. This you have to find. So your formula is Px is equal to P naught into 1 minus mu alpha plus Kx. So you substitute for Px, that is 1000, P naught unknown value 1 minus, substitute for this mu times alpha. What is mu value? 0.55. Okay, so 0.55 into alpha 0.1 plus k times x. What is k given to you? Is wave effect coefficient 0.0015. So 0.0015 into x. Okay. Total span is 12 meters. X means 12. Okay. So this step you just insert it here, and there won't be any. You don't need to write this step. Okay. As the textbook, as he has done this step, he has directly substituted this into this one. Okay. So you don't need to worry. Just avoid this one. Straight away take this step and substitute and insert this step into this. Then you will get the same. Okay. So P naught is equal to 1000 divided by 0.927. That is 1078.7 Newton per mm square. So what is the last value is 78.7 Newton per mm square is last, because jacking hydraulic jack is no, developing 1078.7 megapascal. When it goes to the other end, means because of the friction from jacking, because when jacking is going on, the jack is going to pull the tendon. So each and every point on the tendon is going to have frictional resistance from the concrete or the duct material. So wherever it is moving, so only the point which is not moving is the the anchoring end P. Okay, all other points they are moving towards left. When you say the jacking is going on this way, so all the frictional force acts in the opposite direction. So that is why you will lose some force whatever is developed. So that is what is this one. Okay, right. Going for the next example, a concrete beam AB of span 20 meters is post tension by a cable which is concentric at supports A and B at an eccentricity 400 mm for a length of 10 meters in the mid-span zone. The cable is horizontal in the middle 10 meters portion, has a parabolic profile in the remaining 5 meters near the supports. This is another way of providing the cable. Okay, right. So just CG of concrete and neutral axis. Uh, 20 meters total span, so make this into four equal parts. Okay, so this is five, each 5 meters, 5 5 5 and 5 meters. So middle 10 meters, cable is horizontal in the middle 10 meters, 400 mm eccentricity. Same here, there is no information on what is the size of the member, only the eccentricity value given. So let us assume that 400 is somewhere here, okay, and somewhere here. So it is horizontal in the middle, right? So just straight line is going to make it, okay. Now from this point till the support, there's a parabola. Now you can draw it easily. Drawing straight line is a problem. Drawing a curve is easy. Okay. So this is 400 eccentricity, right? It's 5 meters and 5 meters. 400 is the eccentricity constant between these 2 points. 10 meters span, middle 10 meters. Right. Now slope of the cable at A and B. As this is parabola, we have to use the formula 4E by L. Okay. Remember, this is a parabola, so you have to use the equation of parabola and then differentiate it dy by dx. Okay, that if you substitute, you will have 4E by L. 4 times E is eccentricity, 400, 400 mm, by L is 10 meters. Slope of the cable at A and B. So total portion. 10 meters is the span. Okay, so 0.16, right? Okay, in the middle 10 meters portion, the cable is horizontal, and hence there is no change of slope. Okay, so this is how the uh, cable is being made. Left 5 meters uh, parabola. Then after that, for 10 meters horizontal cable, then the last 5 meters again parabola. Okay. Now change of slope, okay, is like 2 times the slope. Change of slope will be like this. Okay, right. So 0.32 is the value, slope value. Okay. Next, going for only frictional loss, the data provided here is only about frictional loss. Is given mu values 0.35 and k value 0.002 per meter. Estimate the stress in the cable at B if the jogging stress at A is 1200 Newton per mm square. Now P naught is given. You have to find Px. What will be minimum stress in the cable if it is tension from both the ends with a jacking stress of 1200 Newton per mm square? So this is another question. If you do uh, if you put the jocks at both the ends, okay, both the ends we put the jocks, hydraulic jocks. We pull the tendon from both the ends, okay. Then what happens? Okay, so that is the question. Right. Anyhow, loss of prestress, we have to calculate it by the formula P naught mu alpha plus Kx. P naught is 1200, it is known to you, and mu times alpha, mu is 0.35, alpha 0.32, and K times X is span 20 meters. This is the loss of stress. So the remaining stress in the cable is only 1017.6 Newton per mm square. Okay, right. So this is the answer for this question. Estimate the stress in the cable at B if the jacking stress is 1200. So if the jacking stress is 1200, okay, right, just a second. Right, we are working out this one. Yeah, if the jacking stress is 1200, this much is the last value when it no, when it is when you consider the other end of the cable. Okay, so for some portion the cable is parabola and then straight. Okay, so this is how the cable is parabolic and then straight. Okay, right. So if you put a jock at this end and the hydraulic jock is developed 1200 Newton per mm square stress, then if you have jock to only one end, the other end is anchored, then the entire cable length is under friction. Okay, right? Then this is the loss. When you say the hydraulic jock is there at the other end also, so what is happening? The tendon is being pulled from both the ends. So which part of the cable moves towards left? Which part of the cable moves towards right? So from midpoint, half of the length of the cable will be moving to the left because you are pulling this way, and half of the cable will move towards this way because there is a jock at the other end also. So both the jocks are pulling. So friction happens from middle to the end. Okay. So means what? Half the length will come into picture only. I mean this will be just half value 10. So the friction loss will become half 50%. Okay. So that is what is mentioned here. If the cable is tensioned from both the ends, loss of stress can be reduced by 50%. Hence, minimum stress at the center of the span is just half the loss reduced. Okay, so it is 1108.8 Newton per mm square is the stress value. Okay, so this is the question on the okay, what will be the minimum stress of the cable tension from both the ends. Okay, right. So after losses, there will be only 50% losses. This is when you jog from one end. Okay, so when you have jogs from both the ends, friction loss will be reduced to 50%. The reason I told you that when you jog from both the ends, uh, only half of the length will participate in the friction phenomena. The other half will participate in the other jog phenomena. So only half of the length only will be effective. Okay, right? So uh, this is developing 1200. This is also developing 1200. Okay, so the the cable from middle to the left will participate in the friction phenomenon. So only 10 meters. So half of this is the loss. Okay. So 1200 minus 182.4 by 2. That is the stress in the middle. Okay. Midpoint. Because from midpoint, the very next to the right of the midpoint, it is participating with the other jock. Okay. The other jock. This will move like this, and this starts moving like this, right? So half of the cable only will participate in the friction phenomena for a particular jock. Okay, that is how it is. Even if you can, if it is possible, if you jog from the midpoint, okay, you can even reduce uh, again half of the friction loss. So it becomes one fourth. So jacking operation decides or reduces, use more number of jacks for a particular cable, you can reduce friction losses. Okay. So instead of if it is only one jack, if you use for a cable, it will be effective stress will be 1017.6 Newton per mm square. If you use two jacks for a cable, your effective stress will be what is remaining after losses will be improved 1108.8 Newton per mm square. Okay, right. So that's all with this lecture. Uh, uh, so complete unit 3 of your syllabus is being dealt in a full-fledged manner. Okay. Uh, Practice all the problems that we have been discussing in this unit 3, and I'll be posting uh, the assignment sheet for this unit 3. Practice very well. This is going to be the uh, one of the easiest unit for you to follow. Unit 1 is of mostly the properties of the concrete. In the second unit, you have got some pre-stressing systems and also analysis of pre-stress. So problematic part started from half of the unit 2. So if you see overall 3 units, 1.5 unit is of theory content, 1.5 unit is of problems. Okay, so 1.5 unit, like unit 1 and half of second unit is theory. Okay, and the other half of unit 2 is problematic analysis of pre-stress, and complete unit 3 is of problems. Okay, so there is a exactly 50-50 share of theory and problems for the first mid examinations. Okay, so this completes unit 3, which is loss of pre-stress. Next unit we'll take up, which is unit 4, which we will talk about now from 3, 4, 5. All these 3, 4, 5 units are of completely based on design of pre-stressed concrete member. Okay, right. Thank you.